as we prepare for that first test, you have to remember that pre-calculus is about the details. The nitpicky little things that maybe in Algebra 2 you were able to skip are not things you're able to skip anymore. And that's because this is about taking you into a college-level math course. And for a college-level math course, I have to see everything on paper. I can't say, oh, I know Dakota meant this, when I go to the test. I cannot do that. Everything that you want to say to me has to be said on your paper with the details. So let's just go through some of the other things that are totally review here. And example 3 says we are supposed to find the distance d between, and we've got some ordered pairs, so we know it's two-dimensional. So we think back to the distance formula, which is the square root of the sum of the difference between the two x coordinates and the difference between the two y coordinates. So what I have to do when I find those differences is pick a way. It doesn't matter if I go right to left or left to right, but I have to do that consistently for both sets in order to see this. So I'm going to do right to left. 6 minus 1. Oh, I better write that down. I was going to skip a step. We can skip steps after we have one good one down here. And then 2 minus 5. So we go ahead and do the subtraction, and 6 minus 1 is 5 squared, and 2 minus 5 would be a negative 3 squared. And that's going to be the square root of 25 plus 9, which is the square root of 34. Which, if I could simplify it, I have to. That's another part of pre-calculus. We always simplify as far as we can. But there are no perfect squares that are going to divide evenly into 34. So square root of 34 is the best I can do. Now, let's just say this is on a test, and it won't be, but let's just say this is on a test in the future where it says, round your answer. At the pre-calculus level, we always round our decimals to 3 decimal places. And here I am running the words decimal and places together. We are not going to constantly remind you of that on the test. We're not, because it has to become a habit. The reason we do that is because all of the AP exams at the calculus level ask you to go to at least 3 decimal places, either rounding or truncating. So we're trying to teach you a habit, a pattern that's going to be consistent for the next few years that you do math. So 3 decimal places, and we will round in here so everybody is consistent. Do you know what truncate is? Have you ever truncated for anything? Truncated means just drop all the numbers after that decimal point. To a mathematician, that seems kind of silly, but they're saying after the thousandths position, does it really make that much difference anymore? If you're talking about a 10,000th of something, is that really big enough to make a change? So we are going to round our decimals to those 3 decimal places. Again, on this test, we'll want perfect, so square root of 34. Now, midpoint formulas. You can do midpoint one-dimensionally. Kind of silly, because you think, well, wouldn't you just add them together and divide by 2? Isn't that how you get the middle? Yeah, that's exactly what you do. So it is exactly the same thing when you get to 2 dimensions, but let's do the 1 dimension first. So finding the midpoint of a line segment, and it says the midpoint of the line segment has endpoints at negative 9 and 3. I'm going to use a big old capital M here for midpoint. And we would say, well, that's kind of silly because that's negative 6 divided by 2, which is negative 3. But yeah, if we have to find a one-dimensional midpoint, that's what we do. There it is. Now, oh, what did we hide in here? Oh, yeah, visual. It helps, Always remember, 5th grade teacher's number line up there at the top. I mean, if you're ever lost about something, go to the number line and think about what's happening. So we've got negative 9 and 3, and halfway there's negative 3, and it makes perfect sense if you count out the units. Now, more likely, what we will need to use is a 2-dimensional midpoint. And that comes from the fact that what we want to do is find the middle between the 2 x's. So we add the 2 x coordinates together, divide by 2, and then we have to do the same thing with the y's. Where's the midpoint for the y's? add the two y coordinates together, and divide by 2. Seems really basic. For whatever reason, people forget it. And I know what the reason is. Brain research tells us that when something is too easy, if we don't do enough practice at it, our brain says, I'm not retaining this. This was just a piece of cake, and lets it go. You know, there's too much other stuff we have to remember, so our brain says, out you go. I don't need you. Well, we need to know this, but sometimes we have to force our brain through practice to pull that back in. So finding the midpoint of a line segment. The midpoint of a line segment gives us 2 endpoints in 2-dimensional math. So -5 plus 3 would be the 2 x's divided by 2. 2 plus 7 divided by 2. -5 plus 3 is -2 divided by 2. And 2 plus 7 is 9 divided by 2. So that will be -1 and 9/2. Cedar home, do I need that middle step? No. If you can drop the -2 to 2, I'm going to trust that everybody can do that little division in their head. But when I'm writing down notes, I want everybody to see exactly where everything came from. When using midpoints, always think, and I think middle, because it's midpoint, middle, you know. But middle then makes me think average. Putting that connection together, how do you find the average between two numbers? You add them together and you divide by 2. That's how you find the average. So that one is always, it's tough because I give these first tests back, and there's some people that do the old, oh my gosh, I can't believe I missed that. The midpoint formula, there's always somebody that forgets that one. And they're writing me a little note. I know this is easy, I just don't remember it. It just happens. So don't be one of those people. Put a big star by this and come back and take a peek at it before you take your test. Circles. Oh, love the equations for circles. Super easy. Again, we forget them. We do, because it was just too doggone basic. And this might have been one of the things that your geometry teacher had to throw out last spring, because they just didn't have time to get to it, you know. So this one says, use the distance formula and our little figure over here to derive the equation of a circle. So think, all right, square root of difference between the two x's plus the difference between, oh, and I just put a squared instead of a sub. That would be big. There we go. Now, the distance for a circle is important, because the reason a figure is a circle is because this distance right here is constant. It stays the same, and that's what forms the circle. So this is actually the radius, r. Then I start looking at, okay, I got a point that's going to be the center. I've got a point that's going to be on the circle, and I need to talk about what's happening between those two. So I have to find the distance between the x and the h and square it. And then I have to find the distance between the two y's, which would be the y minus k, and square it. But that's not what the equation for a circle looks like, because that square root is just kind of nasty. So we simplify it by squaring both sides. And it'll say r squared equals the quantity x minus h squared plus the quantity y minus k squared. And my k looks a little hinky. And then most of the time, we put the x's and the y's on the left-hand side. So if I have a circle and I want to write an equation for it, just like every other equation, the x and the y's stay put. What we have to put in is h and k. So I go back and I think, well, where were h and k? Oh, that's going to be easy to find because that's the center. So if I have the center, I'm going to put that in for h and k. And then if they give me the radius, I'm going to put that in for r, and I'm going to square it. So there's no little squared symbol there anymore. I'm going to simplify it. So like I said, it's a very basic formula derived from the distance formula. but we tend to forget it. So the standard form of the equation for a circle, we should not be shocked, is exactly what we just derived right up there. X minus h squared plus the quantity y minus k squared equals r squared. There it is. Put in the center for h and k. Put in the radius r and simplify. That's going to be the standard form for an equation of a circle. You're going to have to do this within a week. And it's going to be important to you. So you remember that formula, and you say, well, then it would be x minus a negative 4 squared plus y minus 1 squared equals 8 squared. Well, I'm not going to leave x minus a negative 4. That's not simplified. Cedarholm's going to take off points for that. And I know what 8 squared is. It's 64. And there it is. So again, another thing you want to probably put a big star by, because it's easy. And we forget stuff that's easy. This one over here, if we do x minus 0 squared plus y minus 0 squared, because that's the center, we realize, well, that's just going to be x squared plus y squared. Yeah, that's how we know when a center of a circle is at the origin. When the h and the k drop out, and we get 0 and 0. So, big signal. Hey, this one is centered at the origin, the red one. Circles, circles, circles. Now, oh, I'm sorry. I should have made sure everybody's done with that before I start going. Everybody's okay? Some of you already had the notes from this, and so I'm trying to make sure I don't go so fast that I'm missing the people that didn't. Applications. So what are we going to use this for? We can state that the distance between x and negative 3 is less than 9 using an inequality. Well, sure we can. We have to remember distance is about absolute value. So I'm going to need some absolute value bars. And this one is talking about a number line because they're not ordered pairs. So the distance between x and negative 3 is going to be the difference between those two. And it has to be less than 9. Again, couldn't leave that on a test and expect to get all the points because minus a negative is plus. Those are the little things that make math elegant. Elegant math means perfect math. That is always what we are trying to achieve. The simplest, most perfect answer possible. Precision is huge. So there we had an application, and we also need to put all of this together, and yeah, I got to use the G word, to do a little geometry type of thinking, There are reasons that the distance formula is used so often, and a lot of times it's to prove something. We're not really going to do, remember the 3-column proofs from geometry? 2-column proofs from geometry? We don't really do those in here. We do more of, if we have to do a proof, we do like a paragraph proof where we're just kind of talking people through it. So the Pythagorean theorem and its, there's a blast from the past, converse. Yikes. Anybody remember what a converse is? Geometry's been over a year for you guys. You remember the little if-then statements? Hypothesis and conclusion? If you flip that around, if you flip the if and the then part, you have a converse. So this is saying the Pythagorean theorem in any right triangle, a squared plus b squared equals c squared, where c is the length of the hypotenuse, can be turned around and say, if you do a squared plus b squared equals c squared, where c is the hypotenuse, and it works, then it's a right triangle. So that's its converse. The if and the then pieces are switched. If the sum of squares of the lengths of the two sides of a triangle equals the square of the length of the third side, which is the hypotenuse, then it's a right triangle. So if we can find the lengths of the sides pretty easy to do a little algebraic proof and show, hey, this is a right triangle, because we're going to put it into a squared plus b squared equals c squared to make sure it works. All right, example 8 says, verifying a right triangle. We can do this. Use the converse of the Pythagorean theorem and the distance formula to show that those points determine a right triangle. Okay, if this is on a test, I have to make my work so that it can be followed. Otherwise, I'm going to lose points, because that's my job. I have to make sure that the instructor can follow all my steps. Only way I'm going to be able to do that is if I label these points. All right, so now I've got them labeled, and now I can very clearly tell the instructor I'm looking for the distance from A to B. Because back in geometry, I learned that if you use capital letters and there's no symbols above it, then that's going to be the distance. All right, from A to B, 1 minus a negative 3 is 4 squared. And 0 minus 4 is negative 4 squared. So 16 plus 16, square root of 32. And then I remember, oh, well, 16 goes into that. You know, I have to simplify it if I can. So square root of 16 and square root of 2. 4 square roots of 2. And now it's simplified. Then I need to know from B to C. What are we talking about? What's the distance from B to C? 5 minus 1 is 4 squared, and 4 minus 0 is 4 squared. Hey, look at that. That's going to be the square root of 32, which I'm going to go right to the 4 square roots of 2, because I just showed in the last one that I know how to simplify that. I can skip that little step. Last but not least, AC. 5 minus a negative 3 is 8 squared, and 4 minus 4 is 0 squared, for the square root of 64, which is 8. Now, we actually could have proved something else while we were at it. This is an isosceles triangle. How do I know it's isosceles? Because these two sides came out to be exactly the same. But that's not what we were supposed to prove. We are supposed to prove or verify that this is a right triangle. So it has to work in a squared plus b squared equals c squared. So now I think logically. I don't want to use 4 square roots of 2 in there. Here's why. I'd have to square 4 square roots of 2, and that means doing a 2-step process. I have to square the 4, and I have to square the square root of 2. It's much easier to just go back to the square root of 32 and say the square root of 32 squared plus the square root of 32 squared, does that equal 8 squared? Now, if you did put 4 square roots of 2 in there, as long as you do it right, I'm not going to care. However, this makes it a little bit easier, because you can see these are inverses of each other, so 32 plus 32 equals 64. Oops, and I wrote 36 because I was thinking about writing the 64. And, of course, 64 equals 64. And I think, what was I supposed to do again? What did they want here? Because we really should pull it all together in the end and put it in a little sentence. So use the converse of the Pythagorean theorem and the distance formula to show that they determine a right triangle. Any mathematician can follow your math here. And they can see this worked. But if that explanation was not up there, you might have to think about it a while. You know, what were they trying to do again? So we just make one little conclusion statement here. Therefore, triangle ABC is a right triangle. And we have all the evidence to back it up. That evidence is algebraic. And for mathematicians, that is great evidence. We can see exactly where everything came from. So that was a good one. That's a good problem. Lots of good steps in there. All things we know how to do. It's just that, why am I not seeing the bubble? There we go. All things we know how to do, we just have to put them together. So example 9 says, hey, let's use that midpoint formula. It is a fact from geometry that the diagonals of a parallelogram, why won't that blue stop? There we go. It is a fact from geometry that the diagonals of a parallelogram bisect each other. Prove this with a midpoint formula. Okay. Oh, I love that they gave us a picture already. Already has all the stuff we need on there, but I want to double check it and make sure. Let's see. So here's the origin. This one they just made AB. This one they had to come up with a new variable, so C0. And now this one, they're using the other variables to describe it because you can. You don't want to introduce new variables if you don't have to. So this one says, this distance was A, this distance was C, so to get from here to here, it's A plus C. And it's still the same height as this point over here, so that B is what they can use for the height. So what I have to do is find the midpoints. Capital M of. I'll just go after AC first. Segment AC. Well, that would be A plus C divided by 2, because this is a two-dimensional figure, and B plus 0 divided by 2, B over 2. Now I need to see the other one. And the other one would be OB. Well, let's see. 0 plus A plus C is A plus C divided by 2. 0 plus B is B divided by 2. Well, look at that. They're exactly the same. Well, that makes sense. Because if they bisect each other, they will have the same midpoints. It says prove this with the midpoint formula. So I have to write down what I was just thinking. So the midpoints are the same. Therefore, the diagonals bisect each other. And there wasn't anything fancy about that. You know, it was just, hey, let's show that these midpoints land in the exact same place. They did. Again, it says prove. We get a little wigged out because we remember the two columners, but this is just, hey, let's show the algebra, and then let's explain what we saw. Looks like everybody's got up. Example 10. Prove algebraically that a triangle determined by the following coordinates is an equilateral triangle. Oh my goodness, okay. So that means we have to remember what characteristics an equilateral triangle has. What does it have? Break the word down. Equa and lateral. What's the root word for the equa part in the front? Equal. So they have to be the same. Lateral means sides. All three sides have to be the same. Well, we did something very similar to this just a little bit ago when we were trying to use the Pythagorean theorem to see that we had a right triangle. So we're going to have to figure out what's AB, what's BC, and what's AC. And they better come out the same, or this is not an equilateral triangle. And I notice, oh, this one's a little tougher. Look what they did for the coordinates of B up there. So might have to think a little more, but that's okay. From A to B. 8 minus 3 squared plus 2 plus 5 square roots of 3 minus 2. Hey, the 2's are going to cancel out. Well, 5 squared is 25. But when you square 5 square roots of 3, you have to square both parts. So it's going to be 25 times 3. Because the 5 squared is 25, and the square root of 3 squared is 3. Well, that's 25 plus 75. Oh, like that number. Square root of 100? 10. Oh, I hope they're all that. Well, they're supposed to be. If they're not, we're in trouble. You know, it's supposed to be equilateral. From B to C, 13 minus 8, 5 squared. 2 minus 2 plus 5 square roots of 3. Now remember, you have to think of it this way. So we really would have to distribute the negative. Now, if you don't write down the negative in there, I have to wonder whether or not you knew that. So make sure you're careful about those steps. But again, once we square it, we're going to get the same thing. We're going to get the 10. And then from A to C, 13 minus 3 is 10 squared. 2 minus 2 is 0 squared. Square root of 100, 10. It worked. So we need to say that. Therefore, triangle ABC is equilateral. So they're proofs, but they're more algebra than anything else, with just a little conclusion at the end to tell people, hey, this is what we saw. Here's our conclusion. So that concludes all of the wonderful objectives that we had from P2. So plotting the data on the Cartesian coordinate plane, use the properties of absolute value. No one used the distance formula. No one used the midpoint formulas. No one used the equation for circles. I read those off kind of quick because I want you to grab your yellow. And now that you're done with the lesson, can you rate yourself on those P2s, please? Well, some of you might have already done the homework too, so if you haven't done those ratings yet, go through and fill those in. I know it's hard to remember to do that when you're at home. Totally understand that. Again, I think you guys were probably relatively high with your numbers even to start with, but hopefully those numbers are growing. As we get to newer topics, I'll see a lot more growth because we'll read off the objective and you're just going to go, oh my gosh, I don't even know what that is. You know, you're going to be a 0 or a 1, and if you've heard of some of the words before, you break them apart like we just did with equilateral. But after the lesson, you go, okay, got this. You know, I'm a little higher in numbers. And then after the homework, yes, definitely, this is all good. So now, try and get through some of the P3 stuff with you, because like I said, this is definitely where people shine. You know, it's like we've been solving algebra since pre-algebra, Cedarholm. Well, we know what we're doing here, and so let's rate ourselves before the lesson on, you know, this one you might feel a little bit rusty. Identify the properties of equality. You did that first week in geometry. You did that. You talked about the properties. Correctly solve linear equations in one variable. Solving for x, piece of cake. Can do that. Correctly solve linear inequalities in one variable. So less than, greater than, less than or equal to, greater than or equal to. So maybe not quite so high a rating for yourself on these properties of equalities, but hopefully with this little refresher, They'll start to come back. The first one that we see up here, it says let U, for all the properties of equality, it says the U, V, W, and Z be real numbers, variables, or algebraic expressions. And the first one is the reflexive property. Reflexive, root word, reflect, to reflect. See yourself in the mirror. U equals U. Now, at this level, I hope you're saying to yourself, when would I ever need that? I mean, in math, when does somebody say, well, I need U equals U, so I'm going to have to use the reflexive property to do that? Well, let's just say that you are doing an algebra problem that has required 1.5 pages to get where you are. And you are at a stopping point because you need a new variable. This is how you add one. Right there. You say, okay, I need a new variable, P equals P. I'm going to use that. And you keep going. So it's big. It's just not something that gets used a whole lot until you have a lot of math on your paper. Symmetric, root word, symmetry. If you fold it over, you get the same thing on both sides. That's what's happening here. If U equals V, then V equals U. Transitive, root word, transit. Basically, it's talking about moving. You know, you're going from your home to the light rail, from the light rail down to Minneapolis. But in the end, what you care about is you went from home to Minneapolis. You just had to do it by hooking things together with the light rail. That's what's happening here. Home to the light rail to Minneapolis really takes you home to Minneapolis. Transitive. Addition. Very basic property. You use it all the time. Hey, I need to add a number to both sides of this equation. Addition, property of equality. Hey, I need to multiply. Let's see. If U equals V and W equals Z, well, if I multiply these two together, that's going to equal the same thing as V times Z together. That's not one we use a whole lot. But obviously, because of the equality there, that's going to work. What we care about is how can we use properties to solve. So you let your algebra instincts kick in. What's the first thing they want to do on A there? I see. We're all going to use the stare at it and hope it goes away method this morning. Oh, sorry, I don't want you to miss a chance to stare at it and hope it goes away. It's not going away. It's not working for me. What should we try? Nothing. All right, you all got to sleep in yesterday. I don't think it's fair that you're putting all this on me. I really don't. Try something. If you don't want to speak, I'll walk around and see what you tried. Try something. Yeah, the ones I've looked at, they're distributing. That's what we do. We distribute. We don't want these parentheses here. Wow, is that too much gunk? We like to just have at most 2 terms on each side. So that would mean we need to do some combined and like terms on the left because that's a lot of stuff and it can be put together. So the 4x plus the 3x is 7x. Minus 6 plus 3 is minus 3. That's better. Now we're cooking with gas. So then I think, got to have the x's on one side, the numbers on the other side. And the old standby is take the smaller of the 2 variables and move it over to the other side. So I will subtract 5x from both sides. Then I'll add the 3. Then I'll divide by 2. Oh, I didn't do enough space. Can I cheat and move this down? Will this all move? No, it won't. And I don't want to take the time to lock it, so let me just scoot over here. See at home, do we have to write down all those steps? Yes. I have never seen you do this before. And I asked you how to do it, and you wouldn't tell me. So I have to know that you know how to do this. You got to show all those steps and use the properties of equality, which means, yeah, you really do have to write down minus 5x from both sides, or you're not getting the points. At the pre-calculus level, everything is about a step. You show a step, you get a point. That's how it happens. Now, if it's on the test and I have time, I'm going to throw it back in there and check it, because I'm going to make sure that that works. Even if I just do it with my calculator, I'm going to make sure, because I want all the points. Give B a try. Let's see if we all get the same answer. I tried to do what I think students would do. I don't think most students are going to sit and try to figure out how many times 112 goes into 16 in their noggin. I think they're going to grab a calculator. Unless I made a mistake. Did I make a mistake? Get the same thing? Okay. So again, another one that would be good for a quick check before you turn your test in. Alrighty. Now, you guys weren't here yesterday when I talked about this, but I'm almost positive I talked about it on the videos as well. We talked to Mrs. LaRude, who's teaching calculus here, A, B, and BC, and we always talk to her. She saw all of our material before we printed it all up about, what do you want students to do? We have an old method that we use for solving these, and that old method would be to get it to be a proportion and then cross multiply. It's not the fastest, it's not the best, and anything that slows you down to getting to the point of doing the calculus is bad. So what we would want to do is say, let's clear out all the pesky fractions. The best way to do that is to find the LCD. So we look at 3, 4, and 2, and we discover the LCD would be 12. We multiply all three terms by 12. Noting that here the 3 will go into 12 4 times, and we'll really get 4 times the quantity t minus 1. Here the 4 will go into the 12 3 times, and we'll get 3 times the quantity t plus 5. And here the 2 will go into the 12 6 times. Oh my gosh, now it looks like the two problems we just did. That's the mark of a good mathematician. Saying, you know what? I know how to do those. What one step could I take to get this problem to look just like that? Then let's solve it. Let's see if we all end up at the same place. Looking good? Check my math. It's only Thursday. I'm already exhausted. Looks like this distance learning thing is going to be 10-hour days and then another 2 hours of work at home. Everybody getting negative 5/7? If you didn't, go back and check and see what happened, because it should be negative 5/7. Again, checkable. You can put it back up there. Now, I do want to remind you of, like I said, the older method. Now, the older method could also be people just like working with fractions, you know, and sometimes that happens. You have somebody that says, I don't mind fractions. Fractions are our friends. They are, by the way. But most people don't feel incredibly comfortable with them. So if we have somebody that says, hey, I did the LCD thing, it's still 12. I'm going to make this one a denominator of 12, but to do that, I've got to multiply the top and the bottom by 4. This one by 3. This one by 6. So it'll be 4 times the quantity t minus 1 over 12 plus 3 times the quantity t plus 5 over 12 equals 6 over 12. Well, the goal is, again, to get it to be a proportion so I can cross multiply. But to do that, I've got to put these two together. The two on the left need to go together. So 4t minus 4 over 12 plus 3t plus 15 over 12 equals 6 over 12. Put them together. 4t plus 3t is 7t. Negative 4 plus 15. Whew. Finally, I have my proportion. Now I can cross multiply. So 12 times the quantity 7t plus 11 equals 6 times 12. Hey, wait a second, I just said 12 twice. Now, you could distribute the 12 on the left, and you could do the multiplication on the right-hand side, or you could just say, you know what, I'm just going to divide that 12 out. Because I can. That's a property of equality. And subtract the 11. And divide by 7. And I got the same answer. Did I get the same answer in the same number of steps? No. And that's why Mrs. LaRude says, you know what, teach them to get rid of the pesky fractions, because there's a lot more math we have to do after this. And if this takes too long, well, you're going to have a lot of trouble completing everything that you need to complete. So those are our solvings. And that is absolutely what I wanted to get through with you today. If we keep going, I think I'm pushing too hard. So I will save the rest of this for my recorded lesson for you for tomorrow, I think. And we'll just stop there. Do you want me to put either of the assignments up? Or are you just going to get them off of Schoology anyway? I'll show it to you. So that's going to be the P.3 if you didn't already write that down. Looked like several of you had already worked through the P.2 stuff. Anyway. So the question did come up from one student. What about these sections where we take 2 days and there's only one assignment? Well, that means I mark you present for both of those days when I get your assignment, you know, because your assignment covers everything that we did in those 2 days. So I'm glad to see that the emails that I'm getting about attendance have gone down. I sent out an email yesterday. I'm having everybody reference that. Anything that comes to me anymore about attendance, I am sending out an email that says, please look at the email I sent out on September 16th. Schoology is really, really slow. And when you think about it, it makes sense because almost everybody in the nation is using Schoology now, you know, to submit homework and everything else. So you may think, well, I submitted that yesterday. Why hasn't Cedar Home seen it yet? Because you and hundreds of thousands of other people submitted assignments at that time. And Schoology said, I can't do it all at once. When it does come through to me, it'll say, on time, get full credit for it, I'll be able to change your attendance. But until I see it, I can't do anything. So I have no control over it. It's Schoology that just has to take its time and get in there. I will put it in as soon as I see it and can take care of it.